Hello, everyone, and thank you for joining us this evening for the conjunction of Saturn and Jupiter. It's a pretty nice evening. The seeing, which is the image quality, is not that great tonight, unfortunately, which is why things look a little blurry. But you can see Saturn in the lower middle of the image and its rings, Jupiter at the upper left, and occasionally you can see some of the moons. If we make it bright enough for you to see the moons, which my colleague Alex here is going to do, then you can see that Saturn gets a little saturated, but you can see a number of Jupiter's moons. If you've been looking through a telescope, you can see the motions of Jupiter's moons quite easily over the last couple of nights. So we'll just keep streaming this and playing around with the image settings so that you can enjoy it as you come and go. If you have any questions, we'll be here in the chat for a little while. And if you can ask questions in the chat, that I think that will work on YouTube. And by the way, my name is Roy Gal. I'm the outreach astronomer at the Institute for Astronomy at the University of Hawaii. And the person running the telescope and camera is Alex Gierba. He's an amateur astronomer here, and he helps us out with a lot of our public events. So he's got this nice little setup going for us. So thank you, Alex, and thank you to all of the friends who support us at our public events. Sorry we've missed all of you out in public during the coronavirus, but hope you enjoyed the nice celestial show. So right now you're seeing the actual view from the driveway where we have our telescope set up. And you can see the bright spot. I'll try to zoom in, and this was an image just taken with my iPhone camera. So let's see. You.
This is a lot easier. Try to multitask. I'm trying to figure out Zoom at the same time.
So now I'm going to try to zoom in here on, this is Jupiter and Saturn. I'll put a box around them, and you'll be able to see that even with naked eye, with you can see both of them. If you just use binoculars, you'll get a decent view. I think you might be able to see some of the moons with good binoculars. So that's where Jupiter and Saturn are. You can see the two objects. I'm going to zoom in a little more. Oops. Manipulate the image. There we go. Jesus, it's hard to share.
But we don't want to share.
So for those asking if it happened, this is about as close as they get, 7 arc minutes. The moon is 30 arc minutes across on the sky, half a degree. So this image that you see on the screen now, I just took a few minutes ago from my iPhone, so you can just see what it looks like naked eye. So if you look up, we're looking out over Waikiki. You can see the very bright Jupiter and slightly fainter Saturn off to its right. If you also look up, we have a beautiful moon tonight, and close to zenith, you can also see bright orange Mars. I'm going to switch back to our telescope view now, so you can see Saturn's rings and Jupiter's moons. That'll take us just a minute to switch over to that. 1 second. Okay, so you can start this. So now you have the telescopic view. You can see the rings of Saturn pretty well. You can see a couple of Jupiter's moons. At least I can see them on my screen. If we make it the integration time, the exposure time on the camera a little bit longer, you can see 4 of Jupiter's moons, 2 really close to the bottom and 2 further, 1 a little further out going up, and then another one even much further out, further up and a little bit to the left. So it's Ganymede and Europa on the bottom. So the furthest out moon that you can see up and a little to the left of Jupiter is Callisto, and you can see Io a little bit closer to Jupiter above it in this image. And again, Ganymede and Europa below. And you can see as the atmosphere focuses and defocuses the images, sometimes they look brighter and sometimes fainter. That's what we call seeing. Looking out over Waikiki and over here in Honolulu, it's not that great. That's why we place observatories on places like Haleakala and Mauna Kea. We're above a lot of the atmosphere and you get much better image quality. But it's a bit cold to be outside up there right now. For those that are missing it in other parts of the world where it happens to be cloudy, don't worry, you can still see it tomorrow. It won't, Jupiter and Saturn won't be as close together. They've already actually passed their closest conjunction. We're just a little bit past it, but they'll still be pretty close together tomorrow. So you can go out and check it out. If you've been looking up in the sky for the past week or two, you've watched them get closer and closer and closer together. And I believe the next time they get this close together is in year 2080, when many of us, I certainly will not be around unless I live to be a number I'm not going to tell you. And I think the last time they were this close together was about 600 years ago. So this is a rare sight, but the planets do move around in their orbits, and when they just happen to be in the same part of the sky, then we see them together. Of course, they're not actually together. They're separated by a very large distance. Saturn is twice as far away from the sun as Jupiter. So they just appear lined up. In fact, you can tell that Saturn is further away because Saturn and Jupiter are almost the same size. So if Saturn and Jupiter were at the same distance, they'd look pretty much equally bright. So Saturn is fainter just because it's mostly because it's farther away. For those that are trying to find it, if you look out towards the southwest, so if you're on Townside or Eva, or wherever, look out over the ocean, and from our perspective, it's a really bright dot with a little bit fainter dot next to it, roughly 25 degrees off the horizon right now. For those saying thank you all for joining us. We're glad we could do this and that the weather cooperated. When Alex tested this yesterday in Hawaii Kai, he got clouded out, but I could see it from home in St. Louis Heights, so we decided to set up in my driveway. So you don't need to be any place really special for this. We're just here in town. We're not up on a high mountain. We're not in a super dark spot. So pretty much anywhere you could see this. Yeah. We might actually have a helicopter passing right in front of us. Maybe we'll even get it in our camera. Zoom, you saw that bright light flash through? That was a helicopter just happening to pass by. That's funny. So someone asked, are they going to get closer? I mean, they look far apart in our video feed just because it's a high magnification. If you look in the sky, you'll see it looks like they're almost touching. They've already gotten as close as they're going to get this time around. And we'll be able to observe them for about another hour before they get too low in the sky. As they get lower in the sky, we'll be looking through more atmosphere. So it'll get a little blurrier probably, but right now we're actually doing pretty nicely. You can see Saturn very nicely, and you can see the gap from Saturn's rings quite well. If you want to be really impressed by Jupiter, then you can Google Juno. I'm just going to write that in the chat here. Juno is a mission to observe Jupiter, and it has there are amazing videos of Jupiter's clouds that are in extremely high resolution that show you all the detail and structure and the beautiful colors from the different elements and chemicals that make up the atmosphere of Jupiter. We're just playing around with the exposure time now. So now Saturn looks fainter. That's just because we've reduced the exposure time so that Jupiter isn't too bright. And you can maybe make out one of the bands on Jupiter, the dark cloud bands. So all those images you see of Jupiter with the obvious big great red spot, those are taken with either large professional telescopes on the ground or from spacecraft. So they'll remain, people are asking questions in the chat. They will remain close, but getting further and further separation for the next few days or weeks. You'll see them getting farther and farther apart. They are, as I mentioned earlier, if you didn't join us before, Saturn is twice as far away from us as Jupiter. So even though they look close together on the sky, they're actually incredibly far apart in space. So the next time there will be this apparent closeness to each other, I believe, is in the year 2080. So to put this in context, Jupiter is 550 million miles away from us. We're about 100 million miles from the sun. So and Saturn is twice as far away as Jupiter is. We're zoomed in a little bit to Jupiter here, and occasionally when the seeing gets good, you can actually see that the band of clouds that's visible is red. And once in a while, you can see a dark spot, which is Ganymede's shadow. So there, I'm not sure how delayed the stream is online, but I am seeing the red band of Jupiter pretty well. So now we've zoomed back out and you can see Saturn to the right and Jupiter to the left. And if we integrate a little bit longer, you'll be able to see the 4 moons of Jupiter. So there you go. There's two moons just below Jupiter, Europa and Ganymede. And then a moon farther out upward is Io, and then farthest out is Callisto. And the image is moving around just as we're adjusting the pointing of the telescope as we're zooming around from looking at Jupiter more closely to seeing the entire system. When we're using a digital camera attached to a telescope, a specific CCD camera for astrophotography. So it can expose for a longer period of time, which we need to do to be able to see Saturn's rings and Jupiter's moons, but then Jupiter is overexposed, so it just looks like a white dot. If we expose shorter so we can see the details on Jupiter, as we're doing now, then you can see it becomes very hard to see the moons of Jupiter and Saturn's rings. Even at this zoomed out view, you can sometimes see the biggest red storm system on Jupiter. I see someone asked, why does Jupiter not have phases? Why doesn't it look like a crescent? Only the planets that are closer to the sun than the Earth go through phases. So Venus goes through phases. If you, even with binoculars, if you look at Venus at different times of the year, then you will see that it has phases. You can tell that it's a crescent or only half lit at certain times. Planets that are further out, they don't go through phases because we're always seeing looking at them and seeing the side that's lit by the sun. We don't see them from different angles. We're always looking out towards them. So if you imagine that the sun is a big bright light bulb behind your head, then, and you're looking out away from that light bulb, then everything that you're looking at away from that light bulb will be fully illuminated, bouncing light back to you. So Jupiter and Saturn, Uranus, Neptune, Mars, they always look like a full disk. And in fact, Mars is up now too. So if anyone's outside and looks close to zenith, close overhead, and you see a bright orange star, that is in fact Mars. It looks brighter than, or similarly bright to Jupiter. And the moon's also beautiful. If you just have a pair of simple binoculars, have a look at the moon, look at where the bright and the dark parts join. That's called the terminator. There's no Arnold Schwarzenegger there. It's just the dividing line between light and dark. And right there, you can really see the crater shadows really well. And you can see the three-dimensionality of the moon there really well with just simple binoculars, like birding binoculars, something like a 10 by 50, 10 by 42 power binoculars. If you have more questions, I'm watching the chat as it goes on. So I'm trying to respond to those as I see them. I'd also like to thank, I see Zach Claytor is on here. He's one of the graduate students at the Institute for Astronomy, which is here at the University of Hawaii at Manoa. We are the largest fully academic astronomy unit in the country. We have about 50 PhD astronomers, 30 to 40 graduate students, a large undergraduate astronomy program, and an overall staff of over 150. We have observatories on Haleakala and Mauna Kea. We do astronomy on everything from comets and the sun to the farthest away galaxies. If anyone listening is thinking about a career in astronomy or wants to do an undergraduate in astronomy, please apply to the University of Hawaii. We have a great astro program. And if you're thinking of doing a PhD in astronomy, then Zach will tell you it's a great program. We will not be live streaming this again after tonight because the planets will be separated enough by tomorrow that they won't fit in the field of view of a camera. But if you go outside, if it's cloudy tonight, go outside tomorrow night and you'll still see them close together. And if you have a small telescope, that's all you need. We don't have a big professional telescope set up right now. We have an 8-inch diameter mirror telescope. But even with a much smaller one, 2 or 3 inch telescope, you will be able to see Saturn's rings and Jupiter's, the 4 brightest moons of Jupiter. And that's not just because of the conjunction. Anytime that Jupiter or Saturn are up, you can use your small telescope to see those things. So please go out and enjoy the night sky. There's a lot of great apps on your iPhone, iOS, and Android that let you go see what's up, where you just point to your phone and they show you what's in the sky in that area. There's one called Planets. There's one called Sky Guide. There's a whole bunch, and you can just read the reviews on the app stores and see what people say about them. They have different feature sets, but almost all of them let you just point the camera in a direction on the sky, and they show you what is visible there. Someone asked about tuition, and Zach replied, if you're doing a PhD in astronomy, it's free. Your tuition is covered, and you actually get a stipend that's enough to live off of. Undergraduate tuition at UH depends on whether you're a Hawaii resident or not. I actually don't know those numbers off the top of my head, but you can just look up the University of Hawaii at Manoa and their admissions office, and it shows you what the tuition is. The admissions is done centrally for the undergraduate program. If you're in Hawaii, then after coronavirus has calmed down, we will be back to doing lots of public events. If we would be out probably at Magic Island with a dozen telescopes, and you could be lining up to see this live. But we're glad that we can share this with you online, and that all of you around the world and the country can enjoy it. We'll probably do this more often in the future, now that we see that we can do it quite easily. But we will resume sometimes we will have public talks streaming online in the next semester, but we usually have those live and streamed with astronomers from the University of Hawaii and elsewhere telling us about their research. And whenever we have interesting events like this or lunar or solar eclipses, we go out and we set up. So check us out on Facebook or Twitter. Our accounts are always UHIFA for University of Hawaii Institute for Astronomy. Someone asked about seeing the Christmas star. Well, this is not the Christmas star. This is the almost Christmas conjunction of Jupiter and Saturn. A conjunction is when planets look like they're really close together in the sky. So what you're seeing on screen now is Saturn. You can see its rings. That's the bottom right. And Jupiter, which is saturated, which looks like a big white dot. And if you look closely, you can see some of the moons of Jupiter. Io a little bit up to the left, Callisto even further up, and Europa and Ganymede just a little bit down to the left. Last night I could see Saturn's moon Titan, but I don't see it right now, so I don't know if it's off our screen or just a little bit too faint. We're cranking up the exposure time now, which is why everything looks brighter. Now you can really see Jupiter's moons, and you can see that we've lost Saturn's rings in the brightness, but I don't see Titan right now, so I don't know if it's moved to a location where we can't see it tonight. This is happening live right now. The closest conjunction was a little bit earlier between yesterday and tonight, but it wasn't dark yet here in Hawaii. So we started observing as soon as it was past twilight and dark enough for us to observe. It's really quite beautiful and clear here in the town side. We're here in an area called St. Louis Heights, which is near Manoa and Kaimuki, Palolo. In that part of town, that's where we're observing from. But anyone on this side of the island, I think if you're on the Kailua side, they may be too low in the sky now and blocked by the mountains. I'm not sure. Someone's asking when this was on the East Coast. On the East Coast, you could observe this at sunset just as well if it was clear, but by now they have set. So if you're on the East Coast, you're enjoying our view here in Hawaii now, but you would have had a similar view at your sunset. And someone asked if we do live streams like this. We have not generally done them before because we actually did live observing where people came out. We've had, when we had the transit of Venus, I don't know if anyone of you joined us in 2012, but we had about 10,000 people out on Waikiki Beach and about 2,000 people at Ko'olina and 2,000 people at the Pacific Aviation Museum. That was quite an event. When we've done, we looked at Comet Pan-STARRS a few years ago on Magic Island. We had about 2,000 people there. But we will try to live stream more of those as long as we have internet access from where we are going. That's the biggest challenge. That's why we're doing this from my home, because we have Wi-Fi here. It's not very good internet from Magic Island. So if we can find locations that have good skies, clear views, where we can do public events or we can live stream from, we will do more of these in the future, and we will post information about those to Facebook and Twitter. Well, next May, there will be a total lunar eclipse, which will be visible in Hawaii at something like 1 in the morning. So I am sure we will set up some kind of viewing and streaming for that for those of you who are night owls and would like to join us. We will see what the situation with COVID then. If we can have a public viewing, we will set up telescopes possibly in Kapiolani Park or Magic Island if that's a good location to view from. So, but we have not planned that out yet, as nobody knows what the situation will be then. And those, there are many live streams. There's a website called slooh, SLOOH.com, where they live stream events like that as well. They're unaffiliated with us. They're just astronomy live streaming. In this shot, we just have Jupiter and Saturn. Jupiter is the bright blob, and you can see some Jupiter's moons around it, and Saturn. The moon is in a very different part of the sky, but if you do go outside and look overhead, you get a beautiful view of the moon and Mars.
Let's see. Europa's going to pass behind Jupiter in about 40 minutes.
So the inner moons of Jupiter, Europa, and Ganymede actually have very short orbital times. So we saw Europa separated from Jupiter a little while ago. Now it's right at the bottom edge, the limb of Jupiter. Within 40 minutes from now, it will actually be passing behind Jupiter. So Europa's orbit is actually very fast compared to our moon's orbit. Our moon takes 28 days, of course, to go around the Earth. Europa, on the other hand, only takes 85 hours, so a little bit more than 3 days to make its complete orbit around Jupiter. So if you see the configuration of moons now, if you go out tomorrow and you have a telescope that's sufficient to see those moons, they will look different. And you can go online, NASA and others have websites that will show you what the moon configurations look like. Just about every phone app that is for nighttime observing, you can zoom in and see what the moon configurations are, and it will label you the different moons of Jupiter and Saturn. And we actually do this with our astronomy undergraduate students. We have them map the motions of these moons, and from that, they can deduce their orbital periods and other information. But that's a little experiment you can do at home, watching those moons move around. Yeah, Jupiter, someone said they thought Jupiter and Saturn would be extra bright. They are not extra bright. They're not any particularly closer to us than usual, but they're just very close to each other on the sky. For those who joined us late, Jupiter is 550 million miles from us. Saturn's 1 billion miles from us. So they're nowhere close to each other in space, but they're almost lined up in their orbits right now. The last time this happened was about 600 years ago. The next time it'll happen, it'll be something like 2080. So most of us will not get to experience this again. There are other planetary conjunctions that happen when you see other planets close together. But this one's quite unusual, and it's pretty beautiful because we can see the rings of Saturn and the moons of Jupiter all in one little telescopic image, which is almost never doable. So we just increased the integration time, and now you can barely see the fourth moon Jupiter that's right just touching the bottom edge of Jupiter, it looks like. So it's about to go behind. So you can still see Ganymede, which is the one to the bottom and a little bit right of Jupiter. Then Europa, which is just about to start passing behind Jupiter. And then Io, which is up to the left a little bit. And then Callisto, which is the furthest one. All right, so Alex, who's running the telescope, he's going to point over there to Ganymede, right down there. Europa, when the seeing gets good, is just visible as a dot right at the edge. Okay, and then there's Io, which is right there, and then Callisto, which is the one up there. And depending on the type of telescope you have and what optics you have and how many mirrors are along the way, if you're observing this, you may see a different orientation. But you can tell from the distances which is which. And as I said, these are called the Galilean moons, named after Galileo, who observed them using his tiny telescope that he had at the time. Yeah, if you can only see one bright object and it's lower in the sky, that's Jupiter. If you're on the East Coast, they will already have set. If you're on the East Coast and you see one planet kind of low on the horizon right now, then that's Mars. It'll look more orange. So in Hawaii, Mars is up high in the sky right now, but due to your place on Earth from the East Coast, your perspective, you will see Mars lower in the sky. So if you're on the East Coast, you cannot see Jupiter and Saturn anymore. You could have observed them similarly at sunset, but by now, since it's midnight there, they have already set. They're below the horizon. Yeah, Jupiter is half the distance that Saturn is from us. So I teach my students never to remember these exact numbers, but easy to remember numbers like Saturn is 1 billion miles away and Jupiter is half of that. It's not exact, but it's very close. If you want to give yourself a scale of the solar system, then the sun is about 100 times as wide across as the Earth. And the distance between the Earth and the sun is about 100 times the width of the sun. And then the sun, so that puts the sun about 100 million miles away from us. And Jupiter is 5 times as far away from us as we are from the sun. That means Saturn is 10 times farther from us than we are from the sun. In Ontario, Toronto, oh, you are close to East Coast time then, so this has set already for you. Even on the west coast of the U.S., California, or if you're in BC in Canada, this will already have set because even here it will be setting or very, very low on the horizon within an hour. Yeah, so the sun's distance from Earth, or the Earth distance to the sun, is just under 100 million miles, 91 million miles. The Jupiter is 550 million miles away from us. So the sun is much closer. You can see this tomorrow, but they'll be further separated, so we would not be able to get them into one view on our telescope camera. We're observing from Oahu in Honolulu, from my driveway in St. Louis Heights. So we're not any place special. We are someplace with power and Wi-Fi so that we can bring this to you easily. This is the Saturn and Jupiter have already gotten as close as they're going to get this time around. So this is already a little bit further apart. They don't, a conjunction doesn't mean that they're right on top of each other. It just means that they get very close in apparent distance on the sky. So we'll try to adjust the exposure time for, so there you go, there's the moons. Yeah, for any place on the mainland, this has already passed. Hawaii is, we are the most isolated islands in the world. It's hard to believe for those of you who visited because there's lots of people here. So we are watching this live in Hawaii right now, but for anyone on the mainland, that's California to New York, Vancouver to Newfoundland, you are, this has already set for you. So, and you're staying up late, especially if you're on the East Coast. So for those of you on the East Coast, if you had a chance to go out around just after sunset, you could see this as well. Same on the West Coast, but it's already set for all of you. For folks who are further from us in Australia, they'll get to see it in another few hours when it gets dark there. So someone asked, do they look like a single object in conjunction? So they will not get into alignment like that this time around. I don't know if they ever do, actually. So then they would just look like one object. You can see, if you look naked eye, or even you can look like this on our image, you see that Jupiter is much brighter because it's closer to us. So it would just look like Saturn hiding behind Jupiter. You wouldn't see really any difference. Oh, someone says the thought of how big space is scares you. I actually teach my students a lot about how big space is. Our galaxy that's full of stars is a very busy place in space, and yet it's completely empty. So I like to tell my students that if you think about how special that makes Earth, that should also make you think about how much we should take care of this planet, because there is no place else for us to go. We make a scale model solar system. This might put it into perspective for you all. If the Earth is a sort of grain of sand, smaller than a millimeter across, and then the sun would be about the size of a tennis ball, the Earth and the sun would be about 20 feet apart. Jupiter then would be about 100 feet away from us. Saturn would be almost a whole football field away from us, 2/3 of a football field away from us, and would be the size of a marble, smaller than a marble. So think of the Earth as a grain of sand, and Jupiter would be a small marble about 100 feet away from us. Pluto would be 1,000 feet away from us. And at that scale, the closest star to the sun is the size of a tennis ball. The Earth is a grain of sand. The next closest star to us, Proxima Centauri, would be 1,000 miles away, halfway to California. So even though we look up in the sky and see a lot of stars, the space between those stars is vast and incredibly empty. And that's a busy place in the universe. That's our galaxy, which is filled with 100 billion stars. For someone's asking in South Dakota, your latitude doesn't matter. It depends where you are, east or west on Earth. So whether your part of Earth has rotated this out of view. And yeah, for South Dakota, you can no longer see this. The closest conjunction has indeed passed, but you can still see them pretty close together tomorrow. If you missed it today in South Dakota or someplace else, then you can still see them close, but not quite this close together tomorrow. Maybe we can take a zoom into Jupiter again so you can see some of the details. So here's Jupiter, a little bit zoomed in. You can see some of the cloud pattern. You see the red stripe. Unfortunately, as they're getting lower in the sky, as Earth is rotating and they're setting, it gets blurrier and blurrier because we're looking through more atmosphere. So for those in Canada, no, you can't see it. You could have seen it earlier tonight. Yeah, barring clouds, but it has already set for you in Canada. But go out tomorrow night if it's clear and take a look. You'll still see them close together, just not this close. For those in Europe, same thing. It's already set because Europe is quite far ahead of us in time. 12 hours different, roughly. So 10 to 12 hours different, depending where you are in Europe. So in Europe, this is already rising in the, or getting close to rising in the morning. So they can see it again in the evening. Just always go out shortly after sunset and you'll see them sort of halfway to the horizon from zenith. So everyone on the mainland, everywhere in the world, wherever you are, go out right after sunset and you'll see them. So because of the time zone differences, we can see it here in Hawaii, but for people on the East Coast or Europe, it's already set. For people in uh, Asia, in Australia, it's going to be visible in their evening sky in half a day or a day. Same for Las Vegas. Go out tomorrow night in Las Vegas, it's already set. Right after, so we started observing right after sunset. As soon as it was a little bit dark, we could start seeing Jupiter. So just go out right after sunset, and you have about an hour and a half or 2 hours to about an hour and a half till they set and go below the horizon. So if you wait till late night, or even till you're thinking, oh, I'll wait till it's really dark, then they will have set. Actually, in some places where you have longer nights, you'll have more time to observe them. We're a little bit closer to the equator, so if it gets dark for you earlier, you'll be able to observe them a little bit earlier in the night. So if you're in some place like New York, you can go out at 6 p.m., 5:30 p.m. and see them a little bit higher in the sky. Someone's asking about the scale of the solar system. So again, if the Earth is a grain of sand, so if you shrink down Earth to the size of a grain of sand, then Saturn would be a small marble about 100 feet away from us. So you can go set that up on your street or in your backyard. Take a tennis ball that's the size of the sun, walk 20 feet away from that tennis ball and put down a biggish grain of sand, and that's the Earth. That's our little dot where we live. And then imagine how tiny the islands of Hawaii are on that grain of sand looking at that sun. Someone asked about Kilauea volcano. Kilauea is active, but it's not a huge explosion. Kilauea has a caldera, so a sort of depression in the ground, and that's where the eruption is happening. It's not flowing out from there right now. It is putting a little bit of ash up, but it's not too bad. You can Google, there's quite a lot of, the Hawaii Volcano Observatory has cameras on it all the time. So you can watch it live. It was really beautiful, the images. All right, we're gonna go take a look at Saturn now. Everyone loves seeing Saturn's rings, so we're gonna try to zoom in on Saturn a little bit. All those images that you see of Saturn with the incredible detail in the rings and the clouds, remember, those come from spacecraft that have traveled much closer, or they're taken from very big telescopes using systems that correct for the distortions of the atmosphere, which we don't have on this little telescope in our yard here. But you can still see the fact that there are rings, and you can even see the gap between the planet and the rings somewhat. Yeah, it's getting low in the sky, so it's getting what we would say is soupy or blurry due to the atmosphere. So this conjunction, this closest, the planets are going to get farther and farther apart on the sky as the days go by, but you can still go out and see them for the next week or two close together. In fact, it's a fun thing to do. Go out and see how close they are tonight. Go out tomorrow and then see it, and the next day it's really obvious as they spread further and further apart. So they'll still be pretty close together for the next few nights. I take my dogs out for walks in the evening, so we've been watching them get closer and closer, waiting for tonight. And there's always something going on in the sky. There's a couple of really good websites that have sort of regular updates on things to see. I like Earth Sky, Time and Date. NASA has a great sites. Yeah, so the closest conjunction happened earlier, actually today during the daytime from our point of view. So they're going to be getting further and further apart as we see them for a long time now. Eventually, they'll be so far apart you won't even sort of see them in the same part of the sky. We're really glad that all of you are joining us. This was a last-minute decision to do this and try to stream this live. Alex graciously volunteered that they would try it like 2 days ago. And then we thought, oh, maybe we can post some pictures. And then he suggested, oh, maybe we could live stream. And I said, yes, I think we could do that. So we spent the weekend figuring out how to do it. And here we are. And we're glad that so many of you are able to join us. And we're glad that we got clear skies. I was actually worried for a bit. It looked like we might be clouded out. But we are doing pretty nicely. And while seeing the rings of Saturn and the moons of Jupiter requires a telescope, we want to encourage everyone to go out, just look up at the moon, grab a pair of binoculars and look at the craters. Look, when Venus is up, look at it at different times of the year. And if you have a steady hand, or you can mount your binoculars on a tripod, you can see the phases of Venus naked eye and see how it changes like the moon does over the course of the year. You can see lots of stars. You can see binary stars. There's lots of great things to see in the sky. You can check out things like Astronomy Magazine or Sky and Telescope have excellent articles every month on what's up that month and what part of the sky to go see them. And you really don't need a professional telescope. Sometimes just your naked eye or a pair of binoculars is all you need to start exploring. Yeah. So this is the biggest field of view that the camera can take. We can't zoom out any further, so it's not like we can show you a scale, but I did post a picture earlier of what it looks like on the sky. On the sky, they're easily separated by the naked eye. They're about 7 arc minutes apart right now. That's a measure of angle. So the moon is about 30 arc minutes across. So their separation is about 1/5 of the size of the moon on the sky. Someone asked if they'll be this close again, and I think the next conjunction is in 2080 or something like that. They don't come that regularly. The last one was like 600 years ago. We don't teach online classes, but many places do. There are a lot of great astronomy programs. You can get ones from Neil deGrasse Tyson or Alex Filipenko or many other, Carl Sagan. There's quite a few others. There are a lot of great books. We do public lectures sometimes, and we will be sharing those. If you follow us on Facebook or Twitter, our handle is UHIFA. That's for University of Hawaii Institute for Astronomy. We're a big astronomy institute, the biggest university-affiliated astronomy institute in the United States. And we have observatories on Mauna Kea and Haleakala, on the Big Island of Hawaii, and on Maui. And we do a lot of research. We develop technology. We've developed detectors that are used on the Hubble Space Telescope and James Webb Space Telescope. We are the world leader in surveying the sky for near-Earth objects that could hit Earth with our survey telescopes called Pan-STARRS and Atlas. So nobody finds more near-Earth objects and comets than we do. So we study everything from those kind of objects, asteroids and comets, to the most distant galaxies in the universe and everything in between. Someone's shouting out to some of the spacecraft, Cassini and Huygens and Juno. Indeed, I was saying people, if they really want to see some amazing images of Jupiter, then they should definitely check out the ones from Juno spacecraft. They don't look like what you saw in your textbooks, even from Galileo, the earlier spacecraft. The resolution is incredible, and they're They're quite spectacular to see the complexity of the atmosphere on Jupiter. And there are fantastic images from Cassini of Saturn from different angles. So you can see the detail on the rings and some of the moons and shadows of the moons. They're very spectacular. Yeah, the closest conjunction, we couldn't even see that because that was in the daytime, but they're still very close together. The separation is not much different than at closest. So you're seeing Jupiter on the left and Saturn on the right. And my colleague Alex here will maybe crank up the exposure and we'll point out the moons of Jupiter again. So he's going to point to Ganymede right there. Europa is actually right behind Jupiter right now. If you joined us at the very beginning, when we were observing about an hour ago, we could still see Europa separate from Jupiter, but right now it has started to go behind Jupiter. Europa only takes 3 days and a few hours to go, or 3 1/3 days to go around Jupiter. So even over the course of one night, it does a significant portion of its orbit. So you can see it zipping around Jupiter, just observing in one night. And then we have Io right there, and then Callisto is the furthest one out. And you do not need a big telescope. We are observing with an 8-inch telescope, so the mirror diameter is 8 inches, so that's one you can buy commercially for a few $100s, although we have a very nice mount and camera on it. But even with a small 2 or 3-inch telescope that you can buy anywhere, you could see those moons, as could Galileo, which is why they're called the Galilean moons. Someone asked, how many moons does Jupiter have? That has just changed recently. So Jupiter has quite a few large moons, but it has over 60 moons in total. Some of them are very small. And we keep discovering more of them as we are able to observe with big telescopes and see the tiny faint dots moving around. So right now, we believe Jupiter has 79 moons. 53 of them have been named, and there are another 26 awaiting official naming. We don't just get to name astronomical objects. There's a group called the International Astronomical Union that has the rules for naming astronomical objects. If you are buying one of those certificates that has a star named after you, that goes into a registry by that private company, but astronomers don't use those names. I'm sorry to tell you. That's just a money-making company. The official naming of objects is done by the International Astronomical Union. And there are rules, different kinds of classes of objects can have different kinds of names. So whether they have to be gods or goddesses or other deities or from different kinds of mythologies. We're now taking near-Earth objects that have special orbits, and Hawaiian language immersion students are coming up with Hawaiian names for those objects discovered here, and those names reflect something about the physics or the special orbital characteristics of those objects. And that's done with the Imiloa Astronomy Center in Hawaii. So they are not going, someone asked if they aligned already. In New York, the East Coast, everywhere on the mainland, they have already set. They never actually completely aligned. This is as close as they got to each other on the sky. Yes, someone's saying that's right. The Jupiter is 550 million miles away from us. Saturn is 1 billion miles away from us, but they're just lined up in the same direction from us. Just like a car close to us and a car far away from us on the freeway. They're not actually physically close to us, they're just in the same line of sight. And if you are interested in how we are working to name modern astronomical discoveries with Hawaiian names, I'm posting the URL here. That's done with our colleagues at the Imiloa Astronomy Center, which is in Hilo on the island of Hawaii. They are getting further and further apart on the sky. So the closest conjunction was earlier in the day today, when they were about a fifth of the diameter of the moon apart, the apparent diameter of the moon. The moon is about 30 arc minutes, or half a degree on the sky. And Jupiter and Saturn were 7 arc minutes, which is about a tenth of a degree apart on the sky, a ninth of a degree. We can't zoom out any further than this. This is the full field of view of the camera that we have attached to the telescope, and we wouldn't see anything else at this integration time, I don't think. If we integrate longer, then we can see the moons of Jupiter and maybe if there are any stars, although we're getting pretty low in the sky and we're looking actually, from our vantage point, we are looking out over Waikiki, where all of the big hotels are. So it's actually kind of quite light polluted there. You can't see the moons. So when asked about the other planets, they are not lined up with Jupiter and Saturn now. There are grand conjunctions when you get 3 or 4 planets close together on the sky. That's not this. Mars is visible higher in the sky. So you could see Mars at the same time as Jupiter and Saturn, but in a totally different part of the sky. The next time they'll be aligned, I think, is 2080. If you just Google Jupiter-Saturn conjunctions, you'll find the information. I could do that just as well. Now, the reason this one's interesting is that you do get close conjunctions reasonably often, as someone is saying, but to get them so close together that you can take a picture of both of them or see them both in a single telescope field of view and be able to see the moons of Jupiter is very uncommon. But you can just think of them as race cars going around different sized racetracks, and once in a while they'll pass each other. So we can't get the moons. Yeah, so there's the moons of Jupiter. We've had to crank up the exposure time quite a bit. And you can see Ganymede below and Io and Callisto as you go out upwards. You can also see it's looking blurrier as we're getting lower into the soupy atmosphere here. So I think we'll probably hold on here for another 10 or 15 minutes, and then we're going to say goodnight to everyone before the image quality gets bad and they're getting close to setting. Again, they did not and will not overlap exactly on top of each other. In fact, even if they did, you would only see Jupiter because Jupiter would be in front of Saturn and blocking it. So Saturn would just be behind it, and then all you would see is Jupiter. Saturn would be eclipsed by Jupiter.
disappointing to see this, you know?
So someone says they saw something that looked like an orange cat eye. I don't know about that, but if you saw a bright orange planet in the sky, that was Mars. Mars is brighter looking than Jupiter, and it's high in the sky now at sunset, just after sunset. So you could be seeing Mars. So our solar system has one star, the sun. We have our planets, regular planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then a large number of dwarf planets, including Pluto, the king of the dwarf planets, sadly demoted from being a planet. We have a number of other dwarf planets. Some have Hawaiian names like Haumea, there's Makemake, and more of them being discovered. And it is theorized that there may be a planet, a 10th planet farther out that we have not yet discovered. It would be very faint because it would be extremely far away. But there is a suggestion from the orbits of the dwarf planets that there is some gravitational influence out there that is aligning their orbits, and astronomers are using the observatories on Mauna Kea and in Chile with the big telescopes and the big fields of view to try to find that planet. It may not exist. So it is theorized to exist, but it will be very hard to find because you'd be looking for a very slow moving, very faint object. Someone's asking if they can see it if they go outside tonight. If you are in Hawaii, you can still see it about 10 degrees, 15 degrees off the horizon. If you have a clear view of the west-southwest, if you are on like the Kailua side, then the mountains will be blocking it. But if you're in town or Ewa, Waianae, then you should be able to see it. Hawaii Kai, Portlock, that whole side of the island can see it for another probably 20 minutes or so before it gets really low on the horizon. So someone asked, why don't we always see this? And that's because the planets are orbiting at different speeds in their orbits at different distances from us. And so they are not aligned like this usually. They're just going at different speeds. So if you imagine that they're like race cars on racetracks at different distances from us, going at different speeds, then once in a while one will pass the other, but otherwise they'll be at different places in those circles or those elliptical oval tracks, and we don't see them together. So we just happen to see them right now lined up very nicely. For those who missed it, wherever you are, you will be able to see it tomorrow, but they will be further apart. So by tomorrow, they will be far enough apart that in the camera that we're using, we won't be able to get both of them in the same field of view, but they'll still look quite close together. And if you go out night by night, you'll see them getting farther and farther apart. They'll also be setting earlier and earlier, so you'll see them lower and lower in the sky until they will not be up after sunset, and then they'll eventually start being visible before sunrise in the dawn hours. Oh, I like that someone's telling us they got married today because of the planets uniting. Congratulations on your marriage.
That's great.
I got married on 11/11/11 because we thought that would be cool. You don't get that kind of enumeration anymore. There's 12/12/12, and then you're out of luck for a while. Yes, Saturn's rings are visible through a small telescope. Here you can see Saturn's rings just barely, but it's getting really into the brighter sky from the light pollution and the more atmospheric distortion. Someone asked if humans could live on one of Jupiter's moons. It is mighty freezing cold out there. So, but however, Europa is theorized as a place where you could have life. It is ice covered and has oceans underneath. So people think about sending spacecraft that would drill through the ice and drop a submersible in there to see what's under there. We have life on Earth in almost every extreme environment. They're called extremophiles. They live under a mile of Antarctic ice. They live at the 400-degree geothermal vents at the bottom of the ocean. So life is pretty adaptable, but that's all microbial or very small life. So not things like humans or imagine aliens swimming around. I'm not sure. I think we're going to call it a night here in a few minutes, as we're about to run into my neighbors across the street house blocking the view of the planets, and they're also getting very low in the sky. But we would really like to thank everyone for joining us tonight. Go out for tomorrow night and check out the planets close, and go out and look at the sky every night. Check out the planets. Check out on various websites like Astronomy Magazine, Sky and Telescope Magazine, earthsky.org. Excellent website, earthsky.org, has listings of things that you can see and upcoming celestial events. There's always something to see. And we will keep you posted on our Facebook and Twitter feeds. So please follow us, UHIFA, on Facebook, Twitter. We're also on Instagram, not that much, but we're trying. Our YouTube videos posted here. I believe this video will stay on here after we finish the live. But since this is my first attempt at streaming like this, I'll have to confirm that happens. It is also being recorded from the streaming service we're using. So if that doesn't work, I'll post it in a day or two. So thank you, everyone. Have a great holiday season. I hope you had a happy Hanukkah, a Merry Christmas, a Merry Kwanzaa, a great New Year. And let's all look forward to some vaccine success and a healthier, safer 2021 for all of us. So thank you for joining us. Have a good night, and we will see you in the future.